Perfect. All right. Well, you're actually going to get a 2-for-1 special here on two different projects. One is the one we did that Allison mentioned with the Wisconsin Department of Transportation, looking at salt brine. We also had a project with Clear Roads Pool Fund to look at some recommendations. They both have to do with salt brine and at different temperatures and kind of use some of the similar data with it. So I want to talk about both. But as Allison mentioned, please type in your questions in the chat pod as we go through, and we'll go through it. So I'm sure most of you guys who are on this call today are already aware of a lot of this stuff, but salt has been traditionally used. It is a public and staff expectation about how do we clear our roads? It's salt, right? There's a level of service and there's kind of an experience level with it. But as we know, there are concerns with the salt usage. I was just learning more about what Allison does and kind of this training that goes along with it. But not only is there an increasing cost, which you can see there in the graphic on the right-hand side of the screen, while the cost is increasing, our budgets are not increasing. So we have limited budgets. And then as important as those are, we want to think about the environmental impacts as well too. So whether it's soil, flora, fauna, what you guys are working on here with the surface and underground water, human health, and also the additives. So we know that those are concerns with it. This was done by a colleague, Hillary Dugan, at the University of Wisconsin-Madison. Again, I'm sure that this is stuff that you guys are all familiar with already, but these are kind of the Wisconsin lakes. 8 lakes are illustrated there and showing the long-term chloride trends. Significant urban land cover increases the chloride concentration. And then the forested landscapes kind of stable those concentrations. But we know that there's conclusive evidence of the effect of chlorides in our water, our microorganisms, and our fish and our plants. So the objectives for the study, we had done kind of a pilot study the winter before. So that would have been 2019, 2020, right at the end, or right before, BC, right before COVID. And then we wanted to expand the field data collection from the previous research to add more counties to it and more experience levels. And we wanted to evaluate Wisconsin salt brine applications using kind of 3 metrics. So what is the salt use and salt reduction? The kind of common performance metric of time to bear wet conditions of the pavement friction, which you guys can see me, I'll put in quotations. We'll talk more about what that is, and then the benefit costs of it. We wanted to look at the comparison of salt brine to solid salt use over the winter of 2020 to 2021. And we had study and control routes, which I'll talk a lot more about. So we wanted to make sure our field data collection was under the same conditions in both areas. So I won't get too researchy here, but we wanted to make sure that our studies were done as accurately as possible so that there couldn't be any question about, okay, well, your treatment route was completely different than your control route, right? And so we wanted to make sure we looked at that. So we either did a study in parallel where we had a divided roadway and they salted in one direction and salt brine in the opposite direction. We had a county that did a split study, and it was actually over the county line a little bit. They divided the route into 2 sections. One was salt and the other one was brine. So we can compare the metrics on that. And then we did have some areas where neither of the other 2 were possible. And so we did an independent study where the study and control routes were not necessarily kind of directly geographically located, but they were in a kind of a similar area, right? And so we tried to make sure that the routes had as similar conditions as possible. So similar traffic volume, similar speeds, similar kind of distance away from the sheds and things of that sort. So those were kind of our methodologies in picking the routes. As always, the data collection is so important, and none of this work can be done without our county partners. We can't do any of this work without having people dedicated to collecting this data and getting back to us on a regular basis. So we started with just the basic route information. What was the location? What is the length of it? What are the number of lanes? The start and end points of them both. From the equipment information, we wanted to know what the brine makers were, storage, trucks, spraying systems, the pumps. So those were collected kind of at the beginning of the study. And then for each storm event, we had an online report form that get information from both the study and the control routes. The study, I might say treatment routes as well too. So that was where the treatment was the salt brine, and the control route is our salt usage. We did storm information, weather conditions, and then we wanted to know materials, quantities, application rates, and time to bare wet. So we want to be able to capture all that information. And then the pavement friction. And I know that there's an asterisk next to that, and we'll talk a little bit about that. So usually for pavement friction, why there's an asterisk next to it is that when we think about traditional ways of collecting friction data, it is by a skid test. So you have kind of a wheel that gets put on the roadway and you're pulling it and you're seeing what that force is to pull that stationary wheel through that. Obviously, we can't do that at highway speeds, and there's other issues with it. So we use this advanced roadway weather information sensor called MARWIS to be able to collect this data. And again, the friction is in an asterisk form because it is getting a value of friction with it. And really what we want to do is compare the study and the control routes together to really see about that. The reason why is that we heard from both law enforcement and from the public of, I can't believe you're putting brine down on the roadway. You're putting water down in freezing conditions, and it's just going to make the road icier and more dangerous. So what you're doing is not improving safety or anything else. It's actually hurting safety. So that's what qualitatively we were hearing. And so those of you guys who might know me say, okay, well, let's get to the data. Let's actually see what's going on out there so that we can have hard numbers to compare that to. There's also information with regards to temperature and humidity sensors as well too, which we'll go into. So we did participation of 11 counties, 10 submitted data. There was some staff changes over in the Eau Claire area, so we weren't able to get that. So you can see the red counties there are the storm data. We had 2 counties that were collecting friction data as well, Wood and Jefferson County on that. You can see for the most part, it's pretty spread out across the state. We don't have a lot in the northwest component of Wisconsin, but a fair amount across the state, both north and south in that central location. So I think it was a fairly good representation of our state. So here's the numbers, right? So the first question anybody asks me usually is, well, okay, how accurate is the data? What's the sensitivity of it? And so you can see here, we had storm data reports for 143 storms over those 10 counties. And then for our friction data runs, we had 272 data runs. So obviously over that kind of 30, we have a little larger sample size, which is great to really be able to look at these. So for our data analysis, we did salt use, time to bare wet, and pavement friction. We did a site and group comparison, and we wanted to see if it was statistically significant. So it wasn't just by chance or by randomness that these were different in the results, but we looked at it from a t-test to be able to do that statistics analysis. We wanted to do a benefit cost standpoint. We want to, instead of just looking at the cost of salt brine per gallon, we wanted to look at introducing salt brine applications into existing solid salt applications. So the idea here is that most people are already doing solid salt. So what is that benefit cost of introducing salt brine into your actual work? And we did a horizon of 10 years to say, okay, you know, what would it take to be able to get to that in 10 years? Do you have a benefit cost that's greater than 1 or not? And how many miles does it look at? So those of you who are familiar with salt brine, this is probably kind of a duh situation a little bit, is that because it is a solution, we have salt mixed in with the water, the overall amount salt used by route is less, right? So we can see here that we had a 23% reduction of salt in our study routes compared to our control routes. You can see that p-value there is very, very low. It was statistically significant, which was great to show that, yes, we did have a reduction in salt when we used on the brine on the routes compared to the solid salt that we were using before in that solution. The next thing is something that we use to say, okay, well, how quickly are our roads getting back to normal? So we talked about that as our time to bare wet. So what is the amount of time that it takes our roadways to get back to bare wet conditions on there? And so here we can see by our data that we have here, we had a 12% reduction in time to bare wet. So not only are we using a less amount of salt when we use our brine on our study routes, but we're also seeing a reduction in time to be able to get that back down to that bare wet conditions. So far so good. You can also see that p-value there is below that 0.001, so statistically significant as well. Okay. So pavement friction, right? This was, again, the question that I kept getting when whether it was from the public or on social media or by law enforcement, to say, seriously, Andi, why are you putting water out on these roadways? And so looking at our pavement friction, this is a lot of data here, but what you can see is the control route is in the blue, and the pink route or red route, depending on how you're looking at your screen, is the Brine route, that study route with it. And what you can see is if you look kind of just generally over it, 41 out of the 50 observations had a higher pavement friction value than the regular salt. So we weren't just seeing this as a, it's not, 50% of the time, it's a majority of the time we were seeing higher pavement friction values with the brine compared to the solid salt. So great there. There's another kind of looking at this is called roadway condition. It takes into consideration some of the ice on the roadway and things of that sort, just kind of looking at it that way. 39 out of 46 observations had a higher roadway condition rating as well too. So really good information there. So what we saw was whether it's a pavement friction or a roadway condition rating, pavement friction was 8.1% higher with the study route compared to the control route. And then when we look at the road condition rating was 15% higher. And that, again, that brine compared to our solid salt usage. So good information there to be able to say, okay, it's not just a reduction in the time to bear wet and the salt usage, but it is also an increase in our roadway, right? So this is getting back to our safety of our roadways and looking at it from that regard. What's nice is that we can take a look at the time series component of this as well too, to be able to see, okay, how is this working over time, right? So as Allison was mentioning, they do a lot of outreach and looking at this. Salt brine is one tool and a toolbox for how we can reduce the salt on our roadway. A lot of it's just about education and outreach, and we're still learning more about this, right? So storm fighting, unfortunately, isn't as much as it is a science, it's also an art that goes along with it, based on what is the type of storm that's happening, what is the temperature, is it increasing, decreasing? Is that snow sticky and heavy, or is it light and fluffy? And kind of all of that goes along with it. And using these devices, we were able to track that pavement friction over time to be able to look at it. So what we can see here, this was a storm that we picked out on January 15th of 2021. It was a relatively warm and steady temperature between 30 and 34 degrees there. The graphic in the bottom right-hand side shows the pavement temperature on the x-axis, the y-axis on the left-hand side, and the relative humidity. So you can kind of see how that changes a little bit. The graphic in the bottom left-hand side of the screen shows the snow accumulation and the rates. So you can see how it's kind of popping up over time a little bit. And then really what we want to look at is that the top right-hand side of that screen a little bit, is that you can see that the friction values and how they change over time a little bit. And we can also see the water film height, what's on there, and those kind of vertical dash lines are those materials applied. So what we can see is that pavement friction seems to improve right after the truck applies the material. Again, great. It shows us how quickly brine is working on our roadways, that it's kind of immediately improving our friction values that are out there. But this is, we're still digging more into this and learning more about this, because it really can help show about, okay, how often do the routes need to be with brine and these different characteristics. I know we have limited time and energy, so how do we really fight these storms under different characteristics, and being able to look at that. So we have this data that we can start to go back and look more carefully at through it. So that was on January 15th. This is on January 19th. We had variable humidity and dropping the temperature from 29 to 15 degrees. So again, you can see that kind of in that bottom right-hand side that goes along with it. Here, what we're seeing is because of that dropping, friction is highly correlated to how much water film height is on the water film, kind of that deepness of it, that height that we talk about is kind of really correlated to that. If we had a lot, then it's going to be a lower friction value. And then if that's lower, then we see a higher friction value. So again, being able to really examine that to say, okay, as we're getting this salt brine down and these dropping temperatures, and we're seeing that as it's melting, it's creating some water on there. How do we get that water off? How do we make sure that that water film isn't getting greater than that, and kind of really getting across and out of our roadways, which then we have to be careful of where is it going after that, but we can look into that as well too. And then this was a storm that was done on February 13th, very low temperatures, less than 3 degrees Fahrenheit. It had a formation of ice between 1 to 3 p.m. We did calcium chloride and solemn salt here. And the frequent application improved the friction and reduced the rate there. So you can see in that top right-hand side, you can see those vertical lines of where the material is applied, that ice percentage. And then you can see as we get to that kind of 1 to 3 p.m. there, that the vertical line happens a lot more closer together. So again, it's more frequent application, improve that and improve the friction and reduce the ice percentages. So really good ways to be able to start to look at how do we use this data to make better decisions about when and where people should be out on our roadways fighting our storms. So that was one piece of the kind of the data analysis side of it. And as we talk to our management, it's always about, well, what's the benefit cost, right? So as we change things, there's going to be an increased cost while we change it. How do we look at that? And so the benefit cost is the benefit times the amount of lane miles that would be salt brine routes times the number of storms over a 10-year period divided by the cost over 10 years. So looking at the benefit is that reduction in salt. By using brine, how many would be salt brine routes, and then how many approximate storms would this be good for, right? So as we know, or as we think about salt brine, it's not always, and it kind of can be used equally across all temperatures, right? There are certain temperatures that it works better at than others, and that's what we really want to be thinking about. So this is what we're looking at it. The benefit is our control route, which is our solid salt and our trucking over the lane miles for those storms. The minus is that kind of study route that we want to talk about there is that salt brine, solid salt, looking at the cost of salt, water, electricity, because it takes brine makers, it takes extra work to be able to make this brine up. And looking at that, the trucking costs over those lane miles, that's the benefits of having these. The cost is the salt brine production, those brine makers, the storage and pumps, and the trucks, the salt truck. So we do understand that some salt trucks can be outfitted with brine as well too, but kind of being able to look at that difference in costs. And then plus the maintenance, right? So the maintenance over 10 years, the brine maker and storage pumps, as well as the trucks that goes along with it. We then needed to think about this benefit by storms, right? So as I talked about, brine works better in some conditions than in others, and we really wanted to be able to look at those. And as you can see here, this was the information that we have over a variety of different storm types by temperature. You can see that on the left-hand side there, we can see that there's a lower benefit in the lower temperatures, but as we get up into the higher temperatures, there's a lot greater benefit. And so we kind of needed to be able to compare those, because not all storms are created equal, and we have a variety of different storms in our area. And so again, depending on where you live, you could think about this a little bit differently. If you're in the southern part of the state, you may be over more in this region more often, and maybe if you're in the northern part of the state, maybe you're over in this region. And those are still things we need to look at and examine more closely. And I'll talk about another project here at the end that we did that on. Just gonna check my time here. Okay. So we looked at the number of storms by temperature and snow intensity. We bin those up into these different characteristics. So temperature is less than 15 degrees, and we had a bin of A, which is 15 to 19 degrees, a bin of B, which is 20 to 24 degrees, and then C, which was greater than 24 degrees. We then looked at snow intensity, light versus moderate heavy. Light is less than 5 inches in a 24-hour period. Moderate to heavy is greater than 5 inches in a 24-hour period. Those were kind of 1 and 2. So you'll see in the next slide, we might have like A1, which is a temperature of 15 to 19 degrees with light snow intensity, and being able to look at those. So here's how it all goes. You can see the bins that I talked about before, A1 and A2, the number of storms with it. This was kind of our dollars per lane mile per storm, both our min, mean, and max for each one of those. And then we have our control routes on it with our min, mean, and max. And then this is the benefit. And we use just the mean component of those benefits. As we talked about before, as we go in these like kind of higher temperature areas and the greater kind of light snow, you can really see the difference in those benefits as we go through it. Then we need to try to predict out, right? So, what types of storms are we going to see over a 10-year period is somewhat difficult to do, but we looked at historical data and we kind of classified those. So this is the number of winter storms per season by the different bins. And again, you can look to see up here is kind of the index of what each one is again. And so that 01 is that's less than 15 degrees and light snow a little bit. And you can see how that changes depending on what county that you're in and being able to look at all of those. So then we take those and then add them. We divide times that by our benefit. So we're able to kind of see that through the process. And then we wanted to look at the cost of investment in the lane miles treated by each county. And this is definitely different by county and what they're looking at. Are they looking at interstate or are they just treating interstate and state highways? Some folks are also treating their county highways as well too. This isn't taking into consideration any municipality work. This data was all collected by counties, but you can definitely use something similar. Or if you have questions about how to make this case to your management, please reach out to me afterwards. We'll be more than willing to help you look at this on it. So depending on where you're from, you might be thinking about your municipality or your village mileage as well too. So you can just see the brine maker cost, the storage and loading cost, add-ons to the trucks that happen with it, and then the maintenance that goes along with it for each component. So you can see the investment in maintenance, the dollars over a 10-year period that goes along with it. So we looked at it from each county, the benefit by those bins that we talked about, and then the cost. And so you can see there for each county kind of what we're at there. So, greater than one, a benefit cost of greater than one overall, and then different levels. And again, this is more just by how many mileages, are being treated and looked at a little bit more carefully. So that was just looking at interstate and state highways. As you can see, as we start fighting more of this on our county roadways and including more mileage, the benefit cost goes up, right? And so we see a benefit of trying to do more work with brine than solid salt in some of these characteristics. And so you can see that on this one. So the difference between these two slides is just we're adding those county trunk highways into it as well too. As we think about the results here, just to kind of summarize here, we saw a significant reduction in salt use of 23%. Time to bare wet was a reduction in 11.9. We saw higher friction values and road condition ratings with it. And then overall, our benefit costs are greater than one, especially the more routes, the more lane miles that we use, the greater that benefit cost is associated with it as well too. So we saw a really good summary here of brine is working well. We're seeing it do what we think it's going to do, and then kind of learning from it each and every time that we continue to do work with brine. So, yeah, I think that's kind of self-explanatory of what we've talked about before. So I'm going to go on to a clear roads project that we did. So this was similar in concept with it. This was expanding application rate guidance for salt brine blends for direct liquid applications and anti-icing. So again, just looking to see when brine should be used and what's going on. So what we saw here, the research needs were that there was limited guidance on the actual application rates, especially for liquid de-icers at low to moderate temperatures over a diverse roadway surface conditions. Materials in liquid form can be many different things. So salt brine, which is what kind of focused on with the WSDOT project, but there's also calcium chloride, magnesium chloride, and any agro-based byproducts as well too. So we sent out a survey of practice, and then you can see here we had 31 responses over a variety of different areas. We did have 6 folks responding from Idaho, but everybody else, we got about 1 response from, for the most part, throughout the country. And then this was just kind of understanding what the experience level is, right? So experiencing 94% of the agencies use liquid applications. 70% said that they did indicate that their agencies use liquid applications at pavement temperatures below 20 degrees, which is what we wanted to cover on. We asked if they had guidance available. 67% said they do have guidance for when to use liquids. We did get 11 respondents that submitted their guidance documents to us. And then we asked for what was your commonly used materials. And so you can see here that 22% had selected materials in the survey were for salt brine. We had 18% for solid salt, 17% for pre-wet, 13% for magnesium chloride, and then another kind of category that included a whole bunch of different products there that are listed on that last bullet. We think about kind of what was those liquid application guidance and practices from the pavement temperatures. They said mostly they use it between 20 to 32 degrees. Most agencies kind of avoid using liquids at pavement temperatures below 20, but we did see 4 agencies use liquids at pavement temperatures below 15. There was 47% that used liquid in combination of solid applications. A new term that I got to know as we went through this is that people in the agency or in the industry that you guys are probably familiar with on this call that shake and bake. So it's a combination of that liquid in combination with those solid applications. They also have a 39% used extremely heavy pre-wetting at up to 70 gallons a ton. More talking about that as a slurry. And then you can see the different types of blends that we were able to get back in those survey results. So some good information from there. We always ask kind of how are you measuring this? What are your performance measures through it, and kind of how do you look at that? So similar to what we saw and what we used in the other project was amount of salt use, time of bare wet, cost of materials, friction testing, cycle times, level of service, traffic volumes. They might use automatic vehicle locations or video feed or other information such as road weather information systems as well too. So for this one, we looked at 10 agencies that already had experience with liquid applications, and they indicated their willingness to participate in the study. They collected and provided data for us. We didn't have any agencies that were planning to do it and wanted to kind of get started in our project. So we already had kind of existing agencies that are with this. We did reach out by follow-up calls, say, okay, what is your internal information of commonly used application rates? Making sure that they were willing to participate in the study and gathering more information through the process. So here's our, similar to what we did in Wisconsin, we have the state, the agency, the routes, and the number of storms that we got data from. We had 9 states, 17 agencies, 31 study routes, and 167 storms that went along with it. It was very similar to what we saw. The Wisconsin data is similar to it is the same that we used for the Brine project for WisDOT as well too, but now we're including other states to get a more kind of comprehensive look across the US for this project. So there was a research project 15-01 that was a material application methodologies guidebook. The table down below is something that was in the guidebook there. It's that light snow that's looking at it, and the different pavement temperatures, what is the trend, and then the road surface condition. And you can see those kind of application rates that are on there, right? So all those numbers were great, but what you can see there in the yellow are what was not available in the previous project, and then what was kind of our focus for this research is saying, how do we get to those lower temperatures? Are there application rates that we can suggest for folks to look at? So again, having this information so that as you are kind of coming up with a plan and doing training with your agency, you can say, okay, here's what we were expecting to see under different pavement temperatures. What is that trend? Is it going up, staying the same, or going down? And then what is that roadway surface condition as well too? So we saw a majority of our storms with light snow conditions. Snowfall is less than 0.5 inches per hour. You can kind of see how that broke down here in this table. We wanted to get field-based application rates, knowing what people are actually doing in the field, but then we also wanted to make sure we kind of vetted that information through. So we had a lot of practitioner involvement. These are practitioners that have extensive experience with liquid application. We wanted to share our observed field-based application rates, get their feedback from us. We also wanted to validate our application rates and raise awareness about specific conditions. We did have the guidance that we talked about for the shake and bake was adjusted based on the feedback partly just because we had low sample numbers. And so we wanted to make sure that we wanted to clarify that. The guidance for all other applications, which I'll show you, was based on field data only. So we got comments back from our practitioners that said, yes, that's correct. Go ahead and print those. So here's what the kind of guidance looks like here. And this is actually available on the Clear Roads website now. And I'm more than happy to share this slide deck with Allison so she can PDF it and put it up if it's helpful for folks as well too. So these were liquid applications without blending. What you can see here is the pavement temperature, what is that trend, the road surface conditions, and then what those kind of gallons per lane mile is. And then I think it's always helpful to know is how many storms and what are the locations. So depending on where you are here, if you're from out west or just in Wisconsin or out east, you can start to say, okay, well, does this look kind of like our area as well too? So we have all of that information for each one of these. So this was light snow with magnesium chloride. And then this was a blend, so salt brine and calcium chloride that went along with it. This was another blend of salt brine and geomelt. You can see here, though, there was one storm in one location, or 3 storms in one location. And then we had liquid blending with salt brine, calcium chloride, and geomelt as well, too. So being able to capture that information as well. And so you can see that it was an 80-10-10 blend with it. The shake and bake, so this was kind of that liquid and solid applications that went along with it here. This was one that we did revise based on expert feedback. That is why there's a yellow highlighted note in the top there. And you can see there, so this is showing how much, what is the liquid application values and what's the solid application values. And then as always, where is that field and data details that goes along with it. So I think, again, what you can see here is as we move down here, as we move down in temperature, you're going to see maybe more brine and more solid salt uses as well too. So again, pretty, I think it's what you guys are probably already doing, but just putting numbers to it so you can be able to have that communication with your operators. So our final report included all of the information that we talked about, literature review, survey of practice, field data, application rates, the practitioner feedback that we got, and then the appendices, which I think are the most important. So the available application rate guidance, the survey questions, and then that field data collection forms as well too, to be able to look at it. I obviously cannot do this without our team. So I'm just on there as the associate director, but we have 2 great scientists, Dr. Madhav Chaturi and Dr. Boris Claro. So we're helping with the data collection and the analysis component to it. And then our director, Dr. David Noyce, who's on there as well too. So with that, Allison, I'll see if there's any questions available, and I'm more than happy to share any of this information with folks if they would like it.
All right, excellent. Thank you, Andi. And if you want to end the screen share there, it'll pop up a little bit bigger for people. So thank you so much. Lots of information there to dig through. I'm definitely going to have some follow-up questions for you. And yes, very happy to take and put that information up on our website. A couple questions before I go. I just want to and flip over to audience questions. So if anybody does have any questions right now, please do type those into the chat, and then we can ask those of Andi here. So I guess I first wanted to just check in the storms in Wisconsin where you were using DLA at those colder temperatures. Were there additives there?
There were not.
There was straight sodium chloride. Okay. And then a couple things that I noted, I loved seeing, so the benefit of brine, we see that really across the board, but it is going up when there are more miles, right? Which would make sense because you kind of have this investment in the brine maker and the truck that are kind of like a fixed cost there, right? So when I'm out more often talking to municipalities or talking to private contractors, that they see that upfront kind of capital investment costs, right? That can be pretty scary. And that's why I think we've tried to provide more resources for people to see that there are ways to make brine without buying that Cadillac brine maker, right? Or going in, and a lot of municipalities may be getting their brine from a county, right? Who's gotten a brine maker with support from the state. So that definitely makes sense there. One question I had for your rate, the rates that you're kind of recommending, those were based on this feedback from DOTs largely, right? So there'd be like state highway miles. Would you say that you might adjust those rates for like county highways or like municipal roads if there's less vehicle traffic, maybe less friction there?
That's a great question, Allison. I don't know if I have a good answer to that yet, just because I'm not that familiar with it. So I don't want to guess either way a little bit, but I would say with all of this, you could, start with these rates to begin with, and then tweak it based on what you're seeing in your areas. I think that would be my suggestion is, your audience here is a lot more experts in the field. They know what's going on with it. So maybe start with this. And then as always, we're going to have to kind of reevaluate and change based on it, and then being able to keep track of that a little bit. So for those of you guys who are looking at the live stream, I was talking with Allison about this ahead of time of saying, how do we get some of these best practices out there? Because really it's about sharing the information that you guys are doing in the fields across to one another, right? So are there opportunities for us to share information on what municipalities are doing, what villages are doing, to be able to say, okay, I started here, but really I ended up here. I think that those are really important conversations to have that maybe they're happening and I'm just not aware of them, or if they aren't happening, we should start to do that. So I think it's
we're
really awesome.
Definitely trying to help facilitate those across the state, and a couple of webinars that are coming up that will, dig in a little bit more. We have Bill Kern from Jefferson County speaking about DLA. Yep, I saw him on your study there. That's in August, and Matt Whittam from the town of Lynn will be talking more about brine blends in September. But then, of course, all of the Salt Lives kind of open house events, trainings that we have, we really encourage that kind of cross pollination of ideas and best practices and what's working for one municipality. Because I think so often we are siloed. Mm-hmm. And don't have time for that sharing. So it does look like we've got a little bit of conversation here in the chat. The first question that came in is from Alex. Do you present the findings of the study to people who are upset about putting brine down?
Yes. So we've done a couple different things. So we have WisDOT put out a fairly big press release when we were done with this project, and it went out over social media. And it's always interesting, right? Because you see it come out on social media and you can see all of the comments that come down below it. And it's interesting because I think in this world more than in other worlds, it actually people start to self-police a little bit. And so, before I could even respond back with any comments, people are already saying, no, look at this data, look at that data. And so again, I thought that was really interesting component to this. So there was press releases that have gone out. I've done a couple of interviews based on it as well too. But I think and we are training law enforcement as well too. So we're trying to get to them as well too, so that we kind of cover a little bit of different aspects to it. But I think in having these conversations is so important, Alex. So thanks for bringing that up.
Yeah, definitely see the need for that on our own social media, just in promoting your talk. Saltwise received some negative pushback. Why are we promoting the use of brine that destroys cars and is salt that's going to end up in our water? But as you've shown us from these numbers, like we're using less salt overall, right? So there's less salt that's going into water. There's less total salt that's able to turn into anything that could corrode our vehicles. But sometimes the numbers aren't convincing if you have already made up your mind, I think.
Yeah, and I think it's too this idea that like, oh, the spray is going to come back onto my car, and people just don't, I haven't done it yet, but what I would like, again, in spare time is take a video of brine going down versus salt going down, and to kind of show the difference between that. Salt bounces just as much as brine does as well too, right? And so being able to show that, and then kind of doing like a time-lapse video to show, people are always worried about this spray back that comes up on their cars. Salt does the same thing. And so being able to kind of show that, but it's, again, people they don't see that compared.
Yeah. All right. So it looks like the other comment here is from Kevin. And I know Kevin. Hey, Kevin. He works at the USDA Forest Products Lab, and they have been using brine now for a couple winters. And then this last winter, we're able to start collecting waste brine from their water softener. And we're using that brine for de-icing in the winter. And he said that they have 800 gallons of brine that they've collected, and they're running out of storage space. So if there's anybody in the Madison area who would like free brine, they are willing to give that away. So bringing that cost benefit analysis, bring the cost down, right? And helping that cost benefit analysis work out for people who are interested. So there's still definitely the need for application booms and on your truck or whatever you're going to use for that equipment. But for smaller operators in Madison, you could get started with brine this winter. So I want to pause for just a second. I'm kind of going back and forth between these two screens. If we have, so Alex said, thank you. And I don't see any other questions right now. So I'll give people another minute and just share again that like I mentioned, we have Bill Kern coming in August, talk about direct liquid application, and Matt Wood, I'm doing brine blends in September. But before that, our next webinar in July will be, give me a second, Bob Miltner from Ohio EPA and Kevin Goodwin from Michigan's Eagle, so Michigan's DNR. And they're going to talk about the impacts of salt on our freshwater ecosystems, specifically looking at macroinvertebrates and some of those critters at the bottom of the food chain, and looking at what levels of salt in our streams are impacting those populations. So if you're interested to learn a little bit more about the ecological side of this story, we welcome you next month for that. We do have another comment that just came in here from Corey. Corey is at the City of Eau Claire, and he said, thanks for your team's efforts in sharing this data with us. This certainty helps to compare and contrast our practices with the actual data metrics of others. We appreciate it, exclamation point. So thank you, Andi. And I do know that Corey in Eau Claire is definitely a big proponent of the slurry that you mentioned. And I think he's been using about 80 gallons per ton and has been trying to figure out ways to kind of push that even more. And that actually reminds me of one other thing I thought you'd find interesting for people who are trying to, make it work with equipment shortages right now and supply chain issues. I just met somebody a couple weeks ago. I was at the Salt Brine Summit in Appleton, hosted by Casper's, and Ricky from, I think, Glendale down by Milwaukee has converted an old fire truck to dispense brine. So this will be their first winter using that. So I thought that was pretty creative, innovative solution there.
That's awesome.
Yeah. So, I don't see any other questions or comments right now. They may come in a bit later, but you can put your contact information up there and I can always share with others. So I do thank you, Andi, for joining us today. And I'm going to